Hydroelectric power, a cornerstone of renewable energy. A hydroelectric power plant is a facility that harnesses the energy of flowing or stored water to generate electricity. It is one of the oldest and most widely used forms of renewable energy, contributing significantly to global electricity production. By utilizing the natural movement of water, hydroelectric power plants convert potential and kinetic energy into a reliable, clean, and sustainable energy source. Hydroelectric power is a cornerstone of renewable energy due to its efficiency and low greenhouse gas emissions compared to fossil fuel-based power generation. This technology not only provides electricity, but also supports water management systems, such as irrigation and flood control. However, as with all energy systems, it has its challenges, including environmental and ecological impacts. In this video, we will explore what hydroelectric power plants are, their types, and how they work to power our homes and industries. A hydroelectric power plant is a facility designed to generate electricity by utilizing the energy of flowing or stored water. It works by capturing the potential and kinetic energy of water and converting it into electrical energy through turbines and generators. This process makes hydroelectric power one of the most efficient and reliable forms of renewable energy. There are three main types of hydroelectric power plants, each suited to specific environmental conditions and energy requirements. The most common type is the impoundment plant, which uses a dam to create a reservoir, allowing for controlled water flow and consistent energy production. Another type, the run-of-the-river plant, relies on the natural flow of rivers without significant water storage, making it more environmentally friendly but less reliable during dry seasons. The third type, pumped storage plants, acts as an energy storage system, pumping water to a higher elevation during low demand and releasing it to generate electricity during peak demand. Hydroelectric power plants offer several advantages, making them a popular choice for sustainable energy. They produce electricity without emitting greenhouse gases, reduce reliance on fossil fuels, and often serve additional purposes, such as flood control, irrigation, and water supply. However, there are challenges associated with hydroelectric power plants, including high initial construction costs and potential environmental impacts, such as disruption to aquatic ecosystems and displacement of communities. Despite these challenges, hydroelectric power remains a vital part of the global energy mix. It is a renewable, reliable, and clean energy source that has powered civilizations for over a century and continues to play a crucial role in meeting modern energy demands. Hydroelectric power plants generate electricity by converting the energy of flowing or stored water into mechanical and then electrical energy. This process begins with water, typically stored in a reservoir created by a dam or directly from a river in run-of-the-river systems. The stored water represents potential energy due to its height above the power plant's turbines. When electricity is needed, water is released from the reservoir through large pipes called penstocks. As the water flows through the penstocks, it gains speed and pressure, transforming its potential energy into kinetic energy. This high-speed water strikes the blades of a turbine, causing it to spin. The spinning turbine is connected to a generator, which converts the turbine's mechanical energy into electrical energy using electromagnetic principles. Once the electricity is generated, it is sent through transformers to adjust the voltage and then transmitted via power lines to homes, businesses, and industries. The water that passes through the turbine is discharged back into the river or downstream of the dam, completing the cycle without being consumed or polluted. Hydroelectric power plants rely on a range of critical components to function effectively. The dam and reservoir play key roles in regulating water flow and maintaining energy production during dry periods. Control gates help manage the water flow based on electricity demand, while spillways are used to release excess water during heavy rainfall or floods to ensure dam safety. This process is highly efficient and sustainable, as it leverages a renewable natural resource, water, without emitting greenhouse gases during operation. However, the environmental impact of altering water flow and ecosystems must be carefully managed to ensure the long-term viability of hydroelectric power. Hydroelectric power plants play a crucial role in providing a sustainable and reliable source of electricity to meet global energy demands. They are particularly effective for supplying base load power, which is the minimum amount of electricity required to sustain the grid. In regions with abundant water resources, hydroelectric power plants serve as the primary source of electricity, powering millions of homes and industries with clean, renewable energy. One of the key applications of hydroelectric power plants is their ability to support grid stability and energy storage. Pumped storage hydroelectric plants, for instance, act as natural batteries by storing energy during periods of low demand and releasing it during peak hours. This makes them invaluable for balancing electricity supply and demand, especially as more intermittent renewable energy sources, such as solar and wind, are integrated into the grid. Hydroelectric power plants also have important non-energy applications. Many dams associated with hydroelectric facilities are used for water management purposes, such as irrigation, flood control, and maintaining water supply during dry seasons. These multifunctional roles make hydroelectric plants essential infrastructure in regions prone to water scarcity or extreme weather conditions. Additionally, hydroelectric power plants contribute to economic development by creating jobs and promoting local industries. They support tourism in areas where reservoirs are used for recreational activities like boating and fishing. Furthermore, the low operational costs of hydroelectric plants help stabilize energy prices, benefiting consumers and industries. Despite their environmental challenges, hydroelectric power plants remain a cornerstone of global energy systems, providing not only electricity, but also a range of socio-economic and environmental benefits. They continue to evolve with innovations in technology, ensuring their relevance in a rapidly changing energy landscape. Hydroelectric power plants have both positive and negative impacts on the environment, making their development and operation a topic of significant interest in the context of sustainable energy. On the positive side, hydroelectric plants generate electricity without burning fossil fuels, resulting in zero direct greenhouse gas emissions during operation. Additionally, dams and reservoirs associated with hydroelectric power can aid in flood control, irrigation, and water supply, offering benefits to local communities and ecosystems. However, hydroelectric power plants also have notable negative environmental impacts. The construction of dams and reservoirs can disrupt natural river ecosystems, altering water flow, temperature, and sediment transport. This can negatively affect aquatic life, particularly species that rely on free-flowing rivers for spawning and migration, such as salmon. The creation of large reservoirs may also lead to the submersion of land, destroying terrestrial habitats and displacing human communities. Another environmental concern is the potential for methane emissions from reservoirs. When organic material in submerged areas decomposes under anaerobic conditions, methane, a potent greenhouse gas, can be released into the atmosphere. This is particularly common in tropical regions where vegetation is abundant. Hydroelectric projects can also lead to the fragmentation of ecosystems, impacting biodiversity and altering the balance of local flora and fauna. Additionally, changes in water availability downstream of dams can affect agriculture, fisheries, and drinking water supplies, creating conflicts over resource usage. Mitigating the environmental impact of hydroelectric power plants involves careful planning and management. Solutions include building fish ladders to facilitate aquatic migration, designing fish-friendly turbines, and implementing better reservoir management practices to minimize methane emissions. By addressing these challenges, hydroelectric power can continue to be a vital part of a sustainable energy future while minimizing harm to ecosystems and communities. The future of hydroelectric power plants is poised to evolve as the world shifts towards cleaner, more sustainable energy sources. As a cornerstone of renewable energy, hydroelectric power is expected to continue playing a significant role in the global energy transition. Innovations in technology and design are enabling more efficient and environmentally friendly hydroelectric systems, helping to address many of the challenges that currently limit their adoption. One major area of advancement is the development of small and micro hydropower systems, which can be installed in remote or off-grid locations. These smaller-scale systems have minimal environmental impact and are ideal for powering rural communities, contributing to energy equity and accessibility. Additionally, improvements in pumped storage technologies are enhancing the ability of hydroelectric plants to store energy, making them invaluable for grid stability as more intermittent renewable energy sources like solar and wind come online. Efforts are also underway to make hydroelectric power more environmentally sustainable. For example, the design of fish-friendly turbines and the implementation of better water management strategies are helping to minimize the ecological disruption caused by dams. Researchers are also exploring ways to reduce methane emissions from reservoirs, particularly in tropical regions where this issue is most pronounced. The integration of digital technologies, such as smart grid systems and advanced monitoring tools, is expected to optimize the operation of hydroelectric power plants. These innovations can enhance efficiency, reduce maintenance costs, and allow for real-time responses to changing energy demands. Moreover, the repowering of aging hydroelectric plants with modern equipment can significantly boost energy output without the need for new dams. As climate change intensifies, hydroelectric power plants face both opportunities and challenges. While they can provide reliable energy and mitigate the impacts of extreme weather through flood control, changing precipitation patterns and prolonged droughts may impact water availability. To address this, the future of hydroelectric power may involve a stronger focus on hybrid systems, combining hydroelectric power with other renewable sources to ensure a consistent energy supply. Overall, the future of hydroelectric power plants lies in balancing energy generation with ecological conservation and social equity. By embracing innovation and sustainable practices, hydroelectric power will remain a vital component of the world's renewable energy portfolio for decades to come. Hydroelectric power plants are a cornerstone of renewable energy, providing a clean, reliable, and sustainable source of electricity to millions worldwide. By harnessing the power of water, these facilities play a crucial role in reducing greenhouse gas emissions, supporting energy stability, and driving economic development. They have also proven valuable for water management, flood control, and irrigation, making them versatile assets beyond energy production. However, hydroelectric power plants are not without their challenges. Environmental impacts, such as ecosystem disruption and methane emissions, highlight the need for sustainable practices and innovative technologies. Advancements in small-scale systems, fish-friendly turbines, and pumped storage solutions offer promising pathways for mitigating these issues while enhancing efficiency and accessibility. As the global focus shifts toward renewable energy, the future of hydroelectric power plants depends on striking a balance between energy demands, environmental preservation, and community needs. With continued innovation and careful planning, hydroelectric power will remain a vital part of a sustainable energy future, contributing to a cleaner, greener planet for generations to come.